So what is the next I'm trying to say, children? Let's see. In the adjoining figure, DE parallel to BC. So let me show you DE parallel to BC. We have been given DE parallel to BC. Okay. So this is a figure we are having, DE parallel to BC. Now there are two questions. There are two questions in this. Each of the question has some given data and something to be found out. So in question number 1, they say if DE is 4, mind you, it's in question number 1, DE is 4, BC is 8. So for the time being, temporary, I'm writing here, DE is 4, BC is 8. ADE, area of triangle ADE is 25 centimeters square. Area of triangle ADE is 25 centimeters square. I'm supposed to find out area of triangle ABC. Now children, those who have really listened to me have learned, right now they'll be telling themselves that if I want to find out area, if I want to find out something related to area, there are two properties. One is theorem on areas of similar triangle, and the second is the very first property, the ratio of areas of two triangle. Now the very first property what we studied was ratio of areas of two triangle. It has nothing to do with similar triangles, right? So if you want to find out something related to area, there are only two properties available for similarity. One is theorem on areas of similar triangle, and the second is the very first property, theorem on area of triangles. That is properties, we had 4 sub properties. What do you think? So which one is applicable? The moment I say DE parallel to BC, can we take help from theorem on areas of similar triangle? But sir, the triangles are not similar. So what we do, so we prove them similar? I think so. Sum becomes very simple the moment they give us something parallel. Can I say for triangle DEA and triangle BCA, DE parallel to BC with AC as a transversal, corresponding angles, common angle, are the two triangles similar by A test? Sum is done. Sum is done. So we here start off with our first one, solution. The first one, they say DE is 4, that of BC is 8 centimeter, and area of triangle ADE is 25 centimeters square, all under one roof, I shall say, given. To find area of triangle ABC, but prior to that, we'll prove two triangles similar with the help of those parallel lines. So now we can start off with, now it is DE parallel to BC. This is what DE parallel to BC and AC as transversal. Can I say angle DEA congruent to angle BCA? Equation number 2 by corresponding angle theorem. With this, we would like to switch over in triangle. Which triangle? In triangle DEA and triangle BCA. What can we say? Can I say DEA congruent to BCA? From where did I get it? From equation 2. Sir, angle DAE congruent to angle BAC, common angle. Therefore, triangle DEA similar to triangle BCA by A test. Yes, once we are done with proving two triangles similar, whom we can apply here, theorem on areas of similar triangle. So therefore, by theorem on areas of similar triangles, what can I say? Area of triangle DEA upon area of triangle BCA, or you can say ABC, is equals to DE square upon BC square. Area of triangle DEA given to us 25. Area of triangle ABC, that's what I need to find out. Can I say DE by BC the whole square? Let's substitute the value here only. What shall I get? DE 4, BC 8 the whole square. 1 times 2 times, we take 1 by 4. So what answer did I get? 25 upon area of triangle ABC is 1 by 4. Cross multiplying, area of triangle ABC is 25 into 4, 100 centimeter square. Area of triangle ABC, 100 centimeter square. How about the second part? How about the second part? Let's take first of all the second question also. So what is that second question? What is the given data for the second question? For second one, we shall say given to us DE is to BC is 3:5. Mind you, now we are not going to take this as 25. No longer this is 4 and 8. We have something in ratio. We have something in ratio. DE is to BC is 3:5. So I cannot write down here DE as 3 and BC as 5. If you want, by taking some kind of common multiple, let K be the common multiple, and if you say, sir, can we write down 3K, 5K? Very well. But as of now, I don't think so we need it. I don't think so we need it. Reason? I'm giving the answer. D is to BC is 3:5. Then find area of triangle ADE is to area of quadrilateral. Children, in exam, if these two questions, sub-questions, were given separately, then I have to prove this triangle similar, which I have done so over here once again. But in this R sum, where we are taking both the questions within a single sum, I shall take this two triangles proved similar directly over here. Directly over here. Had I been given only this question, then I'm supposed to prove entire once again. Children, mind you, entire once again. I have to. But since here we have two sub questions, one below the other, we are taking this. So I'm just marking this as Roman number 1. I'm just marking this as Roman number 1. And here we start off with. This is equation number. This is equation number. Now this sum has, other than this sum has nothing to do with this question. No. So let this be my equation number 1. As I said, there is nothing relation. So let this be my equation number 1. This is given. As I stated, if not, you will entirely prove it. But I'm directly saying over here, triangle ABC, triangle ADE, similarity, already proved. So I shall say from 1. We have proved it. Had we not proved it, we are supposed to. Now can I say, therefore, area of triangle ADE, let me write down below. Therefore, area of triangle ADE upon area of triangle ABC is equals to, since the triangles are similar, can we make use of theorem on areas of similar triangle? Is equals to DE square by BC square by theorem. Please do not forget theorem on areas of similar triangles. Theorem on areas of similar triangles. This is the reason I was talking about not to take common multiple. D is to BC, 3:5. Can I say DE by BC the whole square? Is nothing but area of triangle ADE upon area of triangle ABC. Now children, this is already known to us. 3:5 square. Can I say 9/25? Can I say 9/25? So what we have, I'll just jot down once again. Therefore, area of triangle ADE upon area of triangle ABC is 9/25. Mind you, we are not done with our sum. Why? Let's see. What exactly we are supposed to find out in this particular question? We were being given area of triangle ADE. Okay, fine. But we are supposed to find out, we are supposed to find out area of triangle ADE is to quadrilateral DBCE. As of now, what we are having is area of smaller triangle to that of area of bigger triangle. We have as of now area of smaller triangle to that of area of bigger triangle. What we wanted, area of smaller triangle to that of quadrilateral. And what we have as of now is bigger triangle. Any ideas? Yes, there are few who are getting right. There are many who are not in a position to. Let's understand. How will I get quadrilateral is the very first question which should come in your mind. How will I get area of quadrilateral is the very first question which should come in your mind. Answer is so simple. If from the entire ABC, if I subtract ADE, what I'm left with? I'm left with quadrilateral. So from entire bigger triangle ABC, I intend to subtract in ratio. Whenever we talk about subtraction, I reiterate, in ratio, whenever we talk about subtraction, we are talking about dividendo. In ratio, whenever we are talking about subtraction, we are talking about dividendo. And whenever we talk about addition, we are talking about componendo. Whenever we talk about subtraction, we are talking about dividendo. Whenever we are talking about addition, we are talking about componendo. But sir, it is bigger minus smaller. If you apply dividendo at this stage, it will be smaller minus bigger. So the very first step which is going to come over here, by invertendo. By invertendo, flip. So we have a bigger one above. Now can I say by dividendo? So area of triangle ABC minus area of triangle by dividendo. I'll just write down here, please. I'll follow here. So by dividendo, what will I get? By dividendo, it is area of triangle ABC minus area of triangle ABC, mind you, area of triangle ABC minus area of triangle ADE upon area of triangle ADE is simultaneously we are supposed to work the dividendo property on RHS also. 25 minus 9 by 9. From bigger triangle, if I subtract smaller triangle, what I am left with? Area of quadrilateral. DBCE upon area of triangle ADE. How about 25 minus 9? 16 by 9. Are we done? No, we are not done yet. Still we are not done. Why? Sir, you wanted ADE, triangle upon quadrilateral. See the ratio. It is ADE is to DB. And we are having first DB is to triangle. Means once again invertendo. By invertendo. What? Area of triangle ADE upon area of quadrilateral DBCE is 9 by 16. Are we done? No, still not. But sir, we have got it. No, we haven't got the final answer in their language. Their language was is to. We have given the right now in ratio terms. So what we are supposed to write down final answer, that is area of triangle ADE is to area of quadrilateral DBCE is 9 is to 16. Is 9 is to 16. This is what my final answer should be. This is what my final answer is. Right, children? Though within this sum we have learned two sums, what should be kept in mind? Since it is parallel, we proved two triangles similar. We applied theorem on areas of similar triangle. Here, there was something which was interesting compared to the first one. What was it? We were having ratio of smaller triangle and bigger triangle. We wanted quadrilateral. How that quadrilateral can be brought about? Bigger triangle minus smaller triangle. So a couple of dendos being applied. Dendos is my language. First invertendo, then dividendo, and once again on invertendo, we get our desired result.